The next three presentations will be by the Geological Surveys of Poland, Czech and Slovakia in sequence, and will deal with the mode of occurrence and recovery of lithium from hydrothermal solutions, geothermal brines. And the first presentation by Mr. Marcin from the Polish Geological Institute, National Research Institute.
My name is Marcin Pasternak.
Marcin Pasternak. I'm sorry, there was a typo. So Mr. Marcin Pasternak will present to us the details of the potential of the recovery of chemical elements from groundwaters in Poland.
Yes. I want to present a short report about maybe big project in Poland. Potential of the recovery of chemical elements from groundwaters in Poland. Here are my co-authors, Lidia Razowska-Jamorek, Irena Wysocka, Zbigniew Betkowski and Zbigniew Kaczorowski. Recovery project has begun in 2017 as a grant from National Fund. In first step of this project, we have to choose sampling sites. Sites where groundwater is constantly discharged, pumped, mine waters in abandoned mines as well, wells exploiting gas and geothermal and medicinal waters, therapeutic waters. We selected of 67 sites for sampling. It means 18 operating and 9 abandoned coal mines, 3 lignite mines, 12 geothermal and medicinal water plants, 9 gas extracting boreholes, 8 sites of metal ores, copper, zinc and lead, iron, gold, 11 other deposits like salt, sulfur, gypsum and uranium. In these all places we made field measurements like electrolytic conductivity, temperature, pH of waters, as well as obtaining information on hydrogeology amount of discharged water. We also made physical analysis about 65 components, methods ICPOS, ICPMS, ICPMS-CFAST for LEE, and ion chromatography. Here's something like documentation map. Geometric figures shows mineral deposits like hard coal deposits, lignite, metal deposits, hydrocarbons deposits. It means waters associated with natural gas, chemical deposits and geothermal wells. For example, here we have geothermal wells, here we have coal mines in Upper Silesia. After sampled, we perform interpretation. Main assumption we take are concentration of elements in water are stable and do not change significantly over time. Water discharge does not change significantly with time. Capital and operating costs for each mine or plant were not taken into account. Simplified estimation method was used. And here's simply formula for rough counting mineral resources for recovery from waters in relation to pumping rate and taking into account the efficiency. Efficiency we take 80% and working time we take 90%. And here are results of this project. mine waters and geothermal brines in Poland contain resources of valuable elements in every different amounts. In more than half of sites, contents of elements and thus estimated mineral resources are not prospective amounts. Waters in 29 sites contain elevated concentration of several elements prospective for recovery, like bromine, iodine, potassium, lithium, magnesium, manganese. Here we have mineral resources. Red line means maximum pumping rate, and blue the pumping rate, average pumping rate. And here we have major components on all water samples, 70 samples, and we can see, for example, total dissolved solid, TDS, in wide range. Some samples are very high range and some very low, it depends. Here is average, median, and so on. Here we have concentration of some elements in sampled waters, and we looked for anomalies, like here, or for example for lithium, like here. Lithium concentration in groundwater samples in Poland look like on this map. As we can see, 2 points, this and this, Podębice geothermal plant and Dębińsko desalination plant. We have a lot of lithium in here, about 100, and in 4 points a little less. It means 10 to 50 milligrams per liter. On this table we have calculation of 70 sampling sites with some elements. As we can see, the sum of 70 sites in Poland for lithium is about 244 tons per year. Here we have a map with lithium with resources to recovery. Here we have still destination plant Dębińsko is on the first place, and some places in Stargard, Pyrzyce and copper mines in Rudna and Polkowice-Sieroszowice. Here we have sites with resources prospective to recovery, as on this map, and these are these places, and we can recover, for example, these elements. Mine waters, geothermal brines from gas extraction wells in Poland contain resources of valuable minerals of very different amounts. The most promising desalination plant, Dębińsko, have the highest resources of elements to be recovered. 6 elements in concentration perspective is to recover, for example, this lithium also. The recovery of elements from wine, water or geothermal brines is a technology of 21st century, as has something of alchemy, where thousands of tons of harmful substances can be transformed into tons of valuable mineral resources. Mine waters pumped from abandoned coal mine Saturn enriching Brynica River, circa 1,000 tons of various elements annually. As we can see, these elements annually reach Brynica every year. Thank you for attention.
No questions then. Perhaps I'll ask a very basic question. Those brines, groundwaters that had the highest lithium contents, what did they have in common? Which groundwaters, which brines have the highest lithium content of all the hydrothermal waters realm?
The highest concentration of lithium we have in the Dębieńsko desalination plant that are mine waters still pumped in abandoned mines, and also in some geothermal plants. In some of the geothermal plants, it depends.
Marcin, can you tell me what is the main source rock of this brine in Dębieńsko?
In Dębieńsko we have mine water. The concentration of lithium, there is about 100 milligrams per liter.
But what is the source rock?
The source,
What kind of rock?
they are abandoned mines.
But what kind of mines? What kind of ores were there mined?
I can't remember.
Sorry.
I think that it's a carbon water. Yeah.
Yeah, carbon water. Stratigraphy is
Carbonic.
Carboniferous.
Yeah, carboniferous.
But what kind of rock? Carboniferous? Limestone or limestone or sandstone or?
Carbonic means from hard coal. Hard coal.
Oh, coal. I see.
Hard coal.
It was a coal mine.
Tak.
Okay, yes,
Coal
it was a
mine,
coal
yes,
mine.
coal mine, abandoned coal mine.
Okay.
So in other words,
Still the questions, what was the rock around the coal, because the water itself does not come entirely from the coal, you know. So still it can be of interest.
what you're saying, the source of the lithium is the coal seams.
Is the coal. Is the coal.
Is it sure? Surely
Yes.
the coal.
Yes.
Okay, thank you.